Welcome back to Study Smart, and in this video we'll be looking at calculations on what we've discussed in the previous video. So I've talked about these formulas, and these are the standard deviation for population and sample, standard deviation of the mean, and COV, or standard relative standard deviation. So that this is the precision of the mean, and it tells you how far your sample mean is from the true mean. It's also a very good measure of precision. Why this gives your standard deviation in percentage. So I have a question here, and you can see it in the slide. It's actually last year past question, where they just ask them, just want to know how you are able to put these formulas to use. So the question is asking us to calculate the mean and standard deviation one 5. So our standard deviation is 0.15. All right, so a direct titration is the one that we have done in the lab. We have our EDTA in the burette. We have, say, maybe our water that have been buffered with ammonia buffer, and then we have our EBT. Remember, I think we did it in 100 level. We have our EBT indicator there. So we titrate it at the end point. Now do our calculation and get the amount of calcium in the water. So that's a direct titration. Then we also have back titration. This is where your calculation begins to come in. If you are asked, explain back titration, to the past question, you have to first make them know the reason why you use it. If all these conditions are not are fixed, this is the easiest way, the direct titration. But when you now have this condition, no indicator to use, it's slow or it is precipitating, you have to use back titration. If you are asked to explain back titration, you have to first mention the causes why we use it in the first place. This is what we call back titration. We do not titrate it directly, we just titrated it backward. This is where we are coming out. But because of all these conditions, we have to add excess of known volume. The leftover, titrated it. Now we know the amount of the leftover. We subtracted it from the excess. It gives us the amount of EDTA that have reacted with this. And that also automatically is the amount of magnesium that is there. So when we see example, because we're going to do some past questions, they always ask questions on these things every year. So I will solve about 2 or 3 examples from last year and 2 years ago to see how you can attempt this question. The questions are always very long, it looks scary, but as we're doing it, I will just tell you to build your confidence. You don't need to be scared, but questions under this course are always long. If you are not well prepared, you just lose your heart. But if you are calm, you will be able to analyze it very well and get your answer. Okay, so if you look at this question, it says an alloy containing nickel, gold, and iron was treated with H2SO4. You don't need H2SO4 for anything in this question. And make up to 25 ml. Okay. Now this solution was treated with 12.5 ml of 0.02642 molar sodium EDTA. It was further neutralized with NaOH and buffered with acetate. All those ones are story. Okay, so what is the percentage of nickel in 1 gram of the alloy? All right, so now we add an alloy. An alloy is a mixture of various elements. That alloy contained a lot of things. Now we wanted to titrate it. We cannot titrate it directly with EDTA, so we add an excess EDTA. So that 12.5 ml of ratio. Okay, so all these are happening because of the 1-to-1 ratio of the reaction. All right, so you can now go ahead to find the percentage of nickel in 1 gram of the alloy. We're looking at calculations in gravimetry. So after we have prepared our sample and we have precipitated, we have washed, we have minimized impurities. Now we have our precipitate. We have ignited it. We have our precipitate that we want to weigh. Take the precipitate we weigh. Then we need to make some calculations to determine the analyte of interest. Okay, so the first thing we need to write or know is the equation. Like I've said, precipitate weight form is different from the precipitate formed and is different from the analytes. So we need to know the stoichiometry. So for example, this is our analyte, this is our precipitate weight. So what is the number of mole? 2 times the molar mass. That will give us the weight of our analyte. What is the weight of our precipitate? Number of mole, 1 times the molar mass of CHE202. We put it here. The ratio is called the gravimetric factor. Whatever we get here, we put it here. And then this is usually the what makes this gravimetry lose difficult is finding the gravimetric factor and finding the equation. Once you have gotten the equation that balances the analyte and the precipitate weight, and you get your GF, these two will be given in the question. So you just plug it here and get your answer. So we'll look at some past questions. We'll look at about 3 past questions on calculation involving gravimetry. And when we solve this, I believe you should be able to attempt any other question you find. The question shown on our slide is the past question. It says a sample of fertilizer. In this video, we'll be looking at another example. This is actually last year's past question on gravimetry. Okay, so it says a sample is analyzed for the magnesium content by converting the magnesium present to magnesium pyrophosphate. Okay, so I %. Okay, so I believe with these many problems that we have solved, you should be able to tackle or solve any question in gravimetry. If you have any other question or problem in gravimetry, please do well to make me know in the comment section. I'll be ready to answer you. So that will bring us to the end of this topic, gravimetry. In this video, we're considering a question from last year's past question on precipitation titration. Okay, in the last video, I've done the PCl against the volume. Okay, but in this past question, we are actually required to plot PAG. Okay, so I've explained how the graph is going to look like. Okay, so the question is saying that we are given the KSP of AgCl. Okay, so now we want to calculate the silver ion concentration in terms of PAG during the titration of 50 cm cube. Okay, cm cube is the same as ml. Okay, 50 ml of 0.05 molar NaCl. Okay, so it means that see how the PAG kept decreasing. about 26 we have it to be 2.88. Okay, so this is the whole details about plotting a graph or calculating PAG or PCL. If you want to find your PCL from here, you just use this formula and make CL instead of the formula, and you can find your PCL, and then you can also plot the PCL graph to look like the reverse of this. So this is the whole details about plotting and equivalence point on precipitation titration. So in the next video, we'll move on to end point of precipitation titration.